problem from chapter 3, 3.20 or 320. This is also a crashing problem. As you can tell, again, it has normal and crash times, normal and crash costs. And it's a bit more advanced problem than we did in problem number 318. It has more questions or a little bit more complexity, but the process is exactly the same as what we did before. So go to chapter, project management, crashing. In this case, the number of activities goes to G, which is 7. So there are 7 activities. And again, it takes a moment to load. So you can say A through G. And once again, we have to enter the data because we're doing an example from the book. Strongly encourage you to learn the copy and paste feature from MyOM Labs. It will save you, as I've mentioned in previous presentations, will save you a tremendous amount of time, and it will improve your accuracy. Can't do that from the textbook questions. In this case, I just have to present a very rudimentary way. And type the numbers from the book. Now that I've got all the data entered, to answer some of the questions, I'll put them over here on the right-hand side. A, the answer for A is 16 weeks. And you can see it's a little bit hidden in the diagram. Under normal time, which is in column F, row 5. This comes from F5, from cell F5. It says normal time is 16. What is the total cost required for completing the project at normal time? So once again, we have to use the Excel function to total up the column. So use the sum function and select the data. And so this is the answer for B, just total cost. $12,300 normal total cost. So it asks for the total cost for completing this project using normal times. Now, if we want to reduce the cost by 1 week, there's a couple ways we can do it. We can simply go and select project goal, would be 15 weeks. Type that in. But what I'm going to do is I'm going to crash the whole thing. So show crash schedule, and it will do all of them, all the way down to 9. 9 is the absolute shortest period of time you can have. So the answer for C is which activity should be crashed and how much. So the C is $75, and it happens to be activity D, because it is the activity that's gone from 0 to 1. So there's 2 parts you have to read. We went from 0 to 1 for D, so that identifies that D is the activity to crash, and D costs $75 to reduce it by 1. What is the maximum time the project can be crashed? And the maximum time, so to answer question D, maximum time is reduced 7 weeks. So in this particular case, because we're now down from 16 to 9, so 7 weeks of crash ability, and how much will it cost? And that's already given for us in here. Extra cost $1,600. And you can also see that that's also in row 5, column M. The $1,600 is in a couple of places. You could also simply do it on your own. And I noticed I've made a typo mistake. Fortunately, I didn't check affect the answers. The 28,000 I accidentally typed in 11E. It's just 2,800, but it doesn't affect anything. You can also see there's a crash column here rather than reading the table on the right. You can see you're going to crash A by 1 day. B and C, you will not crash at all, which would also identify they're not on the critical path. Because remember, you only crash items on the critical path. D, you're going to crash 4 days. E, you're going to crash 1 day. F, you're not going to crash at all. And G, you're going to crash 2. The reason why that totals up to be more than 7, according to it totals to be 8, because there's sometimes you have to crash more than one activity in a day. And in this particular case, if you look at the detail on the right-hand side, then going from 10 days to 9 days, you now have an A and an E, because it goes from 0 to 1. So on the very last day, you crash A and E. So that's why there's 8 days of crashing, but it only reduces the project by 7. And the reason for that is because then you'd have 2 critical paths. You have to shorten both of them. I hope this has been clear. We will discuss these types of things during class time. Have a wonderful day.